Throughout the ages, the subject of where do we come from has been one of mankind's greatest mysteries, though as of 2021, the most likely scenario for how life started here on Earth is that elements reacted with one another around the edges of puddles, which then formed more complex compounds. To make it easier to understand how life started from just simple elements, it's best to first know what all living things are made of, which is biological cells, such as blood cells and brain cells. Biological cells are the smallest known living thing there is, and are made out of microscopic particles of elements, with the main ones being hydrogen, oxygen, carbon and nitrogen. And where most people would have heard of these elements, most may not know where they come from, and it's where they're from which is the real starting point for our story. Of the 116 elements that are known, 30 are man-made in nuclear reactors, while the remaining 86 are in fact created naturally in the cores of stars. It's then when stars grow old that they either burn themselves out and wither away, or they explode, which are called supernovas, and when this happens, the elements that they contain get shot out into space amongst the debris. The debris from these supernovas form into enormous clouds of gas and dust called nebula, which over millions of years, and given the right set of circumstances, can create a new star. Then, whatever debris is left over after a new star is formed is what will create the planets of a new solar system. Our solar system is pretty much the same as any other, being that it has a sun and planets that revolve around it. But what makes ours unique is that it's the only one that we know of to have life. What you and I call the sun is actually a star, just like all the others up in the night sky, and it formed around 4.5 billion years ago, with the Earth and the other planets forming soon afterwards. The newborn Earth would have looked like a ball of churning lava as it slowly grew, though after about 500 million years it gradually cooled down enough that the lava on its outer edges formed a crust. So with the Earth now covered by a crust, gases that were trapped under the surface began building up and wanting a way out. This led to volcanic eruptions which caused outgassing that sent various gases to the surface, which mixed together to start a type of atmosphere made up of water vapour, carbon dioxide and nitrogen. This new atmosphere would have been like a steamy greenhouse, was certainly unbreathable and didn't have an ozone layer. Then with the Earth still cooling and with so much steam in the atmosphere, clouds started to appear, and with the clouds came the rain. Though the rainfall from this period has been likened to acid rain, as with so much carbon dioxide in the air it would have been unfit to drink. Nevertheless, all the key ingredients for life to start on Earth have come together, this being minerals, water and a suitable environment. Now it would be a fair question to ask, just how do scientists know what the environment was like on Earth back then? Well, as recently as 2017, geyserite rock was found in Western Australia which was dated to 3.5 billion years ago. Now what makes this significant is that geyserite forms in volcanic terrains, so there had to be land for it to form, and it's only found around hot springs and geothermal geysers. So not only does this mean that there was solid volcanic land masses on the Earth's surface, but also that there were active hot springs which are a rich source for minerals. As to what minerals may have been on the Earth billions of years ago, scientists conclude that the minerals that they've found in meteorites which have fallen to Earth in more recent times would be the same as the ones that struck the Earth in its infancy, seeing as how meteorites are just leftovers from when the solar system was forming anyhow. So with the Earth having land masses, when it rained, mineral particles that were scattered about the surface would be gathered up by the rainwater and deposited into puddles rather than flowing out into the sea. And it's in these puddles that minerals reacted with one another and produced the first organic compounds, such as amino acids, which may not have been actual cellular life, but it was the first steps toward it. How this happens is that when a puddle of water doesn't get refilled, the water level either drops or it completely dries out. Now when the water level drops in a mineral-rich puddle, the minerals around the edges stay there, and over time they build up and become more concentrated. Then it's during these dry spells that the minerals become dehydrated and shrivel up. Then, when the puddle fills up again with water, the minerals rehydrate and expand, and it's when they expand that they react with one another and sort of fuse together, resulting in more complex compounds being created. This is known as the wet-dry-wet cycle. There are of course other factors, but this is the basic principle of events that led to the first living organisms, which were single-cell bacteria. So with living organisms now being created in puddles, what also would have begun to happen was that when the puddle's water levels rose during wet cycles, bacteria would have been swept away downstream in the overflow. Then, seeing as how rivers end up flowing out into the sea, eventually some bacteria would have found itself in calm, shallow water at the coast, and it was here that it started using the heat from the sun for energy. These bacteria are known as cyanobacteria, and what makes them so special is that they not only take in the sun's heat, but they also get nutrients from the ocean's water, as well as breathing in the carbon dioxide from the air. This diet made glucose, which turned the carbon dioxide that they breathed in into oxygen that they breathed out. In this toxic environment, the cyanobacteria bloomed, which led it to form into colonies that are called stromatolites. That as of 2019, it's the fossilised remains of stromatolites which are the oldest direct evidence of life that have been found, that were discovered in the Pilbara region of Western Australia and have been dated to 3.4 billion years ago. With the stromatolites making oxygen, eventually the oxygen levels in the Earth's atmosphere gradually rose until it got to the stage that the atmosphere's methane levels dropped. And so now, with an abundance of oxygen in the atmosphere, the ozone layer started forming. No doubt, as technology progresses, so too will our understanding of the past become clearer. But for now, this is the most likely set of circumstances of how life was created on Earth. And what this also means is that with over 200 billion stars in the Milky Way galaxy and over 200 billion galaxies out in the known universe, there's no reason why life couldn't start somewhere else.